Alright, welcome to another Sunday edition of AC with Wacy. Continuing with our indoor air quality series, we will be going over humidity and controlling it within your home this week, but mainly just a bunch of information about humidity and how it affects you and your home. We had several people ask us after we went through the initial videos on spray foam and fresh air control and stuff, how all of that humidity and stuff gets into your home to need to be removed. So this video is more or less covering that. So to start with, we're going to go through what causes the humidity in the home, how the humidity affects your home itself, how humidity affects your health, and what it has to do with your AC, and then how to control the humidity past that point. So basically, how does it affect us? If your humidity is too high, you're going to have mold, bacteria, gonna be stuffed up more. You're gonna feel that heat a lot more. If your house is 70 degrees and you have 60% humidity or 70% humidity, it's a lot more uncomfortable than if your house is 70 degrees and 30 or 40% humidity. If the humidity gets too low, however, it can cause other issues such as colds and infections and your skin being dry and itchy, and it can also damage your home itself. It's worth noting, I never caught this on this graphic till just now, but it's worth noting if your humidity is too high, it can also damage your house's wood, siding, paint, that type of stuff. But we'll go through that here in a minute. So let's start with where it comes from. Humidity in your home has a lot of different sources. In your kitchen and bath activities and appliances. Basically, if you're cooking, if you're boiling water, all of that steam rising off of whatever you're cooking is going into your home and adds humidity to your home. If you run your dishwasher, if you run your dryer, if you are removing humidity or drying out anything in your home, that humidity has to go somewhere. If you hang a towel up to dry after a shower, that humidity that dries out of that towel has to go somewhere, and usually it ends up in the air in your home. There's a lot of different things in your bathroom. You taking a bath, you taking a shower, you running the sink on hot or cold or whatever, and brushing your teeth, washing your hands, rinsing stuff off. All of that stuff can cause humidity in the home. So there's different things that we can do to address those. The first being a kitchen exhaust hood. If you're cooking, if you have a exhaust hood that you can flip on to remove that air as you're cooking, it'll take a lot of that humidity and get it out of the home before it has a chance to circulate out. The same with the bath fan. If you have a bath fan on while you're in the bathroom, taking a shower, taking a bath, brushing your teeth, whatever, all of that stuff kind of addresses the humidity at the point of creation rather than waiting for it to be in your air and be a problem. There's many types of all of these devices. We suggest, if possible, when you're selecting a hood, a vent hood or whatever for your kitchen, that you select one that not only takes out air, but it clicks something in a fresh air device to tell you that you need to add air back. Because remember, in a home, we're all about balancing the air. And if we're sucking air out of the home, we'd rather be bringing air back in. There's hoods that do this by themselves for kitchen hoods. There's ways to wire it with your existing fresh air if you have existing fresh air intake, but bottom line, you're better off removing that humidity at source than waiting for it to be in the home and removing it. Even if you don't have fresh air being put back in, it's a good idea to have a ventilation hood of some sort taking that air up as you're in the kitchen cooking. In the bathroom, One thing that I've just recently started doing it, and I don't know why I've never thought of it before, but contractors get into kind of their own little circles and nobody wants to step on anybody's toes. In our area in particular, for years, the electricians would mount the bath fans. And that's perfectly fine because they have to wire them in. Even though we're providing the ductwork for them, a lot of the time it's just easier for them to mount and wire them in as they're doing their lights and different stuff. So they would always do the bath fans. The only downside to that is there's no real selection on them. Normally they're on a new home, they're going to be they may be a quieter fan or whatever, but they're going to be a fan that basically works off of a switch and you take it out. What I'm trying to do on most of my custom homes, or at least offering as an option and trying to push it, is a fan that works on a motion and humidity sensor. Basically, somebody walks into the bathroom, the fan realizes it and starts up at a low speed to remove air from the bathroom. This helps not only with humidity, but it helps with any smells being generated or anything like that you'd like to remove. But the other thing is a humidity sensor. So basically, if the humidity gets above a certain level in that bathroom, it's going to run to exhaust that air until the humidity is back down below your target point. Like I said, I'm almost it's almost embarrassing that I didn't think of it before, being as that's one of your main generation points of humidity is your bathroom. A fan like that is not only highly efficient and everything, but generally the fans that have those options on them are very, very quiet. So if you're putting in a nice efficient quiet AC system, having that fan kind of works with it and keeps you from hearing that fan in the next room, as well as removing that humidity. Another source of humidity in the home is us people. Basically, and I wrote down some numbers here, that way I'd remember them. But I went through a study that was done by Thomas Greiner, who's a professor of anatomy, and basically he found that 4% of the air that we exhale is humidity, or H2O. That comes out to around 20 milliliters per breath. So that means we breathe out around 192 liters in 8 hours. Now that's a really high number, and you're probably saying to yourself, there's no way there's that much water in my air, and you are correct, because when we breathe in, we are also taking in humidity. So what he found through his study is basically we're breathing in and out, we're basically exchanging air and humidity in and out of our body, but a person adds around 1.3 liters of water per day to the home, which doesn't seem like a lot of water, but that's just, if you have 5 people in your home, you're adding 11 or 12 liters of water to your air. If you're in a very well sealed home, that water can't work its way out, which means it needs to work its way out through a bath fan, a kitchen fan, or your fresh air system, or your AC has to take it out of your air. If you're exercising, you obviously exhale more. You typically take sharper breaths pulling in. You don't get as much in as you're putting out, which is why you become dehydrated, as well as sweating and stuff. So if you have an exercise room in your home, you're probably creating more humidity than your average person in a home. Outside of that, hot air meeting cold air, anywhere that you have heat exchange happening, you have your air conditioner set at 70 degrees, which means it should be blowing out around 50 to 52 degree air. If you have appliances or stoves or anything creating heat that your AC is blowing air on, when those two those two blocks of air meet, it's going to create humidity in the home. And then if you have outside air or air from your attic being pulled through cracks or crevices or straight out holes in your home, that hot air mixing with your conditioned air in your house is going to create humidity. And all of that humidity basically has to be dealt with at some point. So you're probably wondering what our target is. As an HVAC contractor, my target humidity on most of my thermostats is set at 50%. I'll set it lower than that on some homes if you have variable speed systems and stuff that have some humidity control in them. But if you're working with a standard air conditioner, when you're designing for 50% is a lot more achievable. Typically because people don't want their AC running 24/7 and they want to maintain a lower temperature in their home. So you have to size the air conditioner big enough to keep it colder, which will keep it from running longer. So you have to find a balance there, and 50% is a good balance for us, or seems to be. The reason that we want to be in this zone is because, as you can tell on the screen, bacteria grows more between 0 and 30% than it does in the 40 to 50 range. And then on the other side of the scale, between 60 and 100%, bacteria will also grow. But if we keep it in that 30 to 50, 55 range, bacteria has trouble surviving. Obviously, temperature has something to do with this. Aside from the humidity, the temperature in the room will change how much some of this stuff grows. But this was a handy chart, and I didn't want to get that deep into the science, basically. Viruses typically do better between 0 and 40%, and then again from 70 to 100%. Fungus grows only in higher humidity rooms. It's typically going to start around 65 and get up into the 100%. Mites do well between 55 and 100. If you have an infection, your infection gets progressively worse with a drier home. So if you're getting below 30 or 40%, if you have an infection, your infection is going to do worse and take longer to recover from. Asthma is a tough one because asthma hits very, very specific humidity where it's easier to breathe. So 50% is kind of our only spot to where you're really comfortable. If you have asthma or your kids struggle with asthma, high efficiency air conditioners help with this because we can set a target humidity. But you may want to consider putting a dehumidifier or humidifier on your home to kind of keep that 50%. It'll help you breathe better and keep your lungs from having to fight that. Depending on your climate zone, you can either get too dry or too humid. In the area of Texas that I'm in, we fight high humidity more than we fight low humidity. If you're in a desert region, you might fight low humidity more than high humidity. Or if you're in a region to where you heat more than you cool, during the winter time you may need a humidifier to keep that optimum zone going. Chemical interactions do better at higher humidity. If you're spraying a bunch of chemicals, cleaning or whatever, if your humidity's higher, that stuff will kind of linger longer and react differently in high humidity than it does in low humidity. With different climate change and different things that we're aware of and fighting now, ozone production does well with lower humidity than higher humidity. So we want to try to keep it in that 30 to 50 range for that as well. You can see it doesn't really die out till the upper ranges of humidity, and we never want our home at 70 or above. So you're never going to get out of producing that. But If it's something that you're concerned about, you probably need to be in the 30 to 50 range as well. So like I said, typically when I'm designing, when I'm doing a manual JD&S, you select the temperature and humidity that you're targeting in the home. We used to use 75 degrees. Typically we use 70 degrees now, but basically when I design one, most of the time I'm using 70 degrees with the 50% humidity. It is worth noting, if you're building a home and you have an HVAC contractor that you're in contact with, if you're not just dealing through the builder, or if you are dealing through the builder, try to express to the builder where you normally set your thermostat. It seems kind of like a small detail, but it's a pretty important detail. If I design a home to be set at 70 degrees and maintain 50% humidity, if you move into the home and you set your thermostat at 75 to 80 degrees, that's not going to control the humidity like I designed it to do. It's probably going to be oversized. It's going to short cycle more often. It's not going to pull that down. On the flip side of things, if I design it for 75 degrees and you set it at 70, it's going to control the humidity really well, but it may not maintain the temperature that you're aiming for. Most of our designs, if you're doing it through a program like RightSoft, which is what I use, we're using numbers accumulated from weather data, and when we set our peak load, we're setting for our average high temp. If you were in Texas this last summer, you know that we were much warmer than an average high temp. Typically, we're designing for around 100 degrees. A lot of last summer was 105 to 115, and our designs just did not hold up as well. That being said, we can't really design for 115, because again, if we design for 115, your system becomes more and more oversized. It runs in short cycles in the lower temperatures, and you have trouble controlling the humidity. But anyways, that's kind of going off in the weeds on the air conditioning stuff, but that's why we're aiming for 40 to 50%. That's why we need to know a temperature when we design it, and that's why we typically use the 100 degree mean rather than using 110 for our designs. How the AC affects your humidity. I just mentioned the short cycling issue. If you have an AC that is size too large for your home, essentially it will turn on. It will change the temperature of the home very, very quickly. It may be able to take your home from 75 to 70 very quickly, and you look at your thermostat and you feel better about that because you think that you just saved power by sucking the temperature down that far. The problem is that an AC basically is using that temperature exchange to pull condensation out of your home. It leaves via your condensate drain. So if your AC is on for 5 minutes rather than 15 minutes, you don't get much temperature exchange across that coil. It happens very, very quickly. It doesn't sweat. You don't remove that humidity from your air. And so we're typically trying to keep air conditioners running 10 to 15 minutes at a time. Anything less than 10 minutes is considered a short cycle. Depending on the publication or the study that you read, there's a lot of them that say anything less than 15 minutes is a short cycle. Again, we're typically designing for a high temperature and trying to maintain a certain percentage in the home as far as humidity, and that's what we're aiming for. Single speed air conditioners will only be able to achieve that optimum temperature and humidity setting at that design temperature. They'll do a pretty decent job Obviously, we're trying to design to go into all situations, but you have to pick one for your optimum, and that's usually where we set it. A 2-speed air conditioner will step down and allow it to run longer to get more of that humidity exchange. And then a variable speed keeps in mind all of those things and is trying to maintain the humidity as well as the temperature, so they work very well. The other thing with air conditioners that will affect this somewhat is, say you don't have a spray foam home and yours is normal insulation, it's a 1950s construction or older or whatever. If you oversize this home, there's only so much air inside of your home. So if you oversize this home and you are sucking more air up through your return than there is in the home, and then you're putting that air back down, it's putting a lot of pressure on the inside of this house, sucking air in near your return. So anywhere by your return that there's a gap where there's a construction joint, there's a pipe going out the wall, there's a gap in your floor when you're not on a slab, or anything around a window or your fireplace, all of these places will suck in outside air. If it's sucking in 100-degree air, that's going to create humidity in the home. If your humidity is high outside and you're sucking in that air, it's going to create humidity in the home. If it's sucking air out of your attic, typically that's going to be hot, humid air, and that adds it to your home. So all of these things are made worse by an oversized air conditioner. Again, an oversized air conditioner is going to leave more of that, but it's also creating more inside your home via cracks and different things that it's pulling in. The other thing that your air conditioner affects with this is if you have any of these particles, these bacteria, viruses, etc., that we're trying to keep out of our system, we don't really want to be breathing in. That stuff is all going to be circulated around your home via your air conditioning system. So that's why we deal with it as much as anyone. Again, we're not just cooling air, we're conditioning air. We want to try to maintain a healthy air inside the home. That being said, once we've come to the conclusion, all right, we need to control this humidity, cracks in the home and all of these things are adding to our problem. The best way that we can control the humidity and the temperature and the health of your air is to control the building itself. That means that you want to build tight. You want your envelope to stay an envelope. A lot of people, they'll look at this tight construction that requires fresh air intake and dehumidifiers and all these things, and they'll say it's better to just build the old way and allow your home to breathe. Allowing a home to breathe is very important. Personally, and as an HVAC designer, I would rather that I control the breathing of the home. I would rather that I have an HRV and ERV that is bringing in and putting out a specific amount of air. An HRV, so I had this question after the fresh air video and I didn't really address it, but an HRV is exchanging air and filtering air, and it's trying to exchange some of the temperature between the inside and outside to treat that air to kind of mix the conditioned air with the outside air, so that if it's 100 degrees outside, you're not just pouring 100 degrees into your home, you're kind of balancing it as it's exchanged. An ERV goes one step farther and it tries to isolate the humidity on each side of the envelope so that you're not putting in humid air and you're not putting out all of your conditioned air. It tries to do a more efficient job of controlling that as it's exchanged in and out. But anyways, so ideally we're controlling this space by having a tightly built home. there's a lot of ways you can do this better. I would suggest something like the Build Show with Matt Risinger for advice on how to do that. But one thing that I wish more builders in our area would do is a zip system rather than sheathing and paper on the outside before your sheetrock. The zip system is a sheathing board with insulation, and then they have tape and caulk and different stuff that works with it to seal the cracks between the board, where your screws go, where your nails go, where your penetrations go, and try to seal all of that before you ever spray your spray foam. And then again, spray foam helps the penetration of all of those materials. I was going to look it up and I didn't, but anyways, so the air coming into a normal home, say it's at 100 particles. It's not, I can't remember what the number is, but say it's at 100. If you go to open cell spray foam, that number will drop down to 10. It'll basically pull it down by 70-80%. When you drop to closed cell spray foam, it's almost 10% of that again. Again, these numbers aren't 100% accurate. It's been a while since I took the class, and I was going to write them down for a refresher and forgot to. But it drastically reduces the amount of air being exchanged in and out of the home, which is a good thing for air quality. It's a bad thing for budgets a lot of the time, because when you're building the home, you have to add in all of this fresh air and humidity control and things. But 10 years down the road, when you've been breathing controlled, conditioned air and eliminating a lot of the particles that you breathe in that cause different diseases or problems down the road, you'll thank yourself for spending that extra little bit at the beginning. So again, our air conditioner being properly sized is keeping from pulling in extra air. It's making sure we get some of the humidity out as it runs, and that we're not just circulating bad particles through our air. There's different ways to control humidity. These little thermostats here, you can buy one at Walmart for 20 bucks. I would suggest in almost any home that you buy this, or you can buy a more expensive one, but if you're curious what your humidity is, or you've never tracked it, or you don't have a thermostat that tracks it, go spend 20 bucks, buy one of these little thermometers that registers humidity, put it in your home, see what your home normally has. Put it into your attic, see what your attic is running. If your attic is running 70, 80, 90% humidity, you need to look at ventilation or dehumidification in your attic. All of this stuff, it does us no good to control our home space if the other half of our home in the attic is building mold and bacteria and viruses and all of these things. That stuff will leak into your house eventually. If not into your home, it'll be into your walls and your come through your outlets and different stuff, and you'll be dealing with it for years. So I suggest that you go spend 20, 40 bucks, whatever, put one in your attic, one in your home. Know what your indoor air is. The first step to addressing any problem is finding what problem you have. If you don't know where your humidity is running as far as a level, then you don't know if you need to pull more humidity, if you need to add humidity to a home. If your temperature on your thermostat is dropping too quickly to remove humidity, you'll be able to tell that. It's just a good investment. On the right here, we have this one, I believe is an HRV. It should be an ERV, but they look similar. But anyways, the ERVs will control some of that humidity in and out. Again, an HRV still helps because it's trying to control that temperature, but an ERV is a better system for it. They are more expensive because they're a more complicated piece of equipment, But if you're putting them on, a lot of the time in a southern climate, you want to go ahead and do the ERV. If you're in a northern climate to where you run heating more than you run air conditioning, an HRV will suffice a lot better. Just because you're not drying out your air by heating all winter long, you're getting some fresh air with some humidity in. Again, in the north, and the second picture here is a humidifier. We don't typically use these where I'm from. We rarely deal with low humidity in the home. If you're running heat 24/7 for months on end because you live in a northern climate, you want to have one of these to add some humidity into your home to save cracked skin, dry skin, creating viruses, warping the wood in your home, etc., etc., etc. And then on the left here we have just a normal dehumidifier. I like the Santa Fe ones. There's cheaper models on a lot of new construction if budget is constraining. I use one that's made by a company called Alor Air. It's ALORAIR. It's about half the price of a Santa Fe or an April Air or a Fantech. They work fairly well. They're a little noisier, but they get the job done, I guess. The Santa Fe ones I'm a big fan of. I've only recently started using some of them, but they are very good machines. They're very quiet. Overall, I'm aiming towards using Santa Fe dehumidifiers and Fantech air exchange machines everywhere I can. April Air makes good products all the way around as well. But these devices will be something that you can add on to control your air. You need to know if your AC is properly sized. If you have a home to where you've got high or low humidity, you need to check to make sure you don't have too much heat in your home for low humidity and it's sucking all of the moisture out of your air by heating it up too fast. If you've got too much humidity, you're probably in a cooling climate and your air conditioner may be oversized and basically leaving that humidity in the air. The other thing that does is use more power. If you're kicking off a 5-ton air conditioner when you could get by with the 3, you could save a whole lot of power by cutting back to the 3-ton. If you're adding insulation and sealing your home and changing your windows and doing all of these things to get your home tighter and more efficient, please don't use the same size of air conditioner you've always used. I know not everyone can change it out at the drop of a hat, but if you're doing all of these things, when you change that air conditioner out, have a manual J, D, and S done. The manual J, D, and S will tell you what size you need. It'll be able to size it for a humidity level and temperature level, and you'll be much better off. I had a customer this week that was wanting to redo his duct system, and he's going to re-insulate his home as well. And he had been talking about his indoor air quality just not being great, and he thought maybe it had something to do with the air leaking in through his windows and different things. And when I looked at redoing his duct system, I did a duct design, and to do a proper duct design, I did a manual J, D, and S. I walked around his home, drew out the rooms, the windows, the doors, and then did an actual load calculation, and wouldn't you know it, his air conditioner was a ton oversized, and that's before changing his insulation. If he goes through with re-insulating, he'll still be about a ton oversized with the insulation that he's doing. But if in the future he were to seal his doors and windows, or cover the doors and covering the doors and windows with shade makes a lot of difference on your air conditioner. But all of these things, if you do all of these things to make it more efficient, but you're still running the biggest air conditioner they sell, you're probably leaving humidity in your home. You're probably producing a lot of these problems. So if you're trying to control the humidity, you want to run clean air in your home. You can add in filters and UV lights and stuff like that. We highly suggest that to kill off mold particles and bacteria and spores and all of this stuff. But on the other end, be combating it by not allowing more to be produced. And the way that you do that is controlling the humidity in your home. It also keeps your wood from rotting. The stain on your floor is affected above 60 to 65%, I believe is what I was told. Cabinets in your house, the food in your house, the doors, the windows, everything can either be warped below 30% or be affected above 60% when they get too much humidity. So bottom line, humidity affects a lot of things in your home. You need to know your home. You need to know your air conditioning system. You need to know your fresh air. All of these things affect all of it, and basically that's why we're doing air conditioning and not air cooling. But I know this video, I was not as eloquent as some others probably. Kind of bounced between AC stuff and humidity stuff, but it kind of goes hand in hand. And to be honest, I had a very busy week, so I didn't have as much time to prepare. But that's humidity and how it affects your home. If you have any questions or you feel I missed anything, please let me know and I'll get back with you. If you want to do a manual JDNS of your house to see if your AC is oversized, undersized, etc., if you're in our area, you can call us to have us come do that. As far as measuring it out, if you have a set of plans, you can send me a PDF of a set of plans and I'll do that for you. If you walk around, draw me a rough sketch of your house, just know I need to know what windows you have, what doors you have, the type of windows and doors, their size, what direction the house is facing, the type of roof that you have, the type of insulation that you have, the type of siding that you have. All of these things will affect that manual JDNS. So if you decide to go that route, you're outside of our area, feel free to send it to us and we'll try to work it out for you, but you do need to know some details about your house. You can contact us. People keep telling me that I forget to include my email. It's wacey@brazosriverac.com. If you're on our YouTube page or Facebook page or website, you should be able to find that. Our phone number is 817-864-1412. You can always message us on Facebook, leave us a comment on YouTube, and all of that good stuff. If you would, please subscribe to the channel if you found it useful, and let us know if you didn't, and we'll try to improve. Thanks for stopping by, and we'll catch you next week.